Good morning. Today we will learn about two scientists, C.V. Raman and Homi J. Baba. So let us begin. C.V. Raman. Okay, this is we must give importance to this scientist C.V. Raman. As you all know, he's an Indian scientist who was born in Tamil Nadu. Then he won Nobel Prize for Physics in 1930 for his work on scattering of light and also for the discovery of effect named after him. Hope you all know it is nothing but Raman effect. So first of all, you must write the points. He is an Indian scientist. Then he got Nobel Prize in Physics in 1930 for his two works. One is on the scattering of light and also for the discovery of Raman effect. Then he has completed his bachelor's degree from Presidency College, Chennai, and he also was awarded a lot of scholarships and in order to pursue his master's degree. And he has a great potential in doing his laboratory works. Then, while he was doing master's degree in 1906, he published his first academic paper, and that was on the topic unsymmetrical diffraction bands due to a rectangular aperture. And later, that was published in a philosophical magazine. Then he also worked as a civil servant in the Indian Finance Department in Calcutta for 10 years. Then in his free time he carried out research. Then he also did most of his research work at Indian Association for Cultivation of Sciences, IACS. In addition to his research work, he also delivered a lot of public lectures in Calcutta, which mainly intended to popularize science. Then most of his research works were very much impressive in those days, and he was widely recognized as a talented physicist. Then he also got another scholarship named from University of Calcutta. It offered him a palette research professorship. Then let us discuss some of his discoveries. First was about he noted about the blue color of sky, and he investigated why sky is always blue or why sea is always blue. So blue color of sea. Okay. Scientist Raleigh, he explained that sky looks blue because of elastic scattering, a phenomena which is later named after his name, that is Rayleigh scattering. He explained that the sea's color is blue just because of the reflection of the sky's color. Okay. Now, Raman, when he was on his way to British Empire at Oxford, he was traveling in his flight on a deck of a ship in across Mediterranean Sea, and so during his journey, he looked at the beautiful blue color of the Mediterranean Sea, and he just doubted about Raleigh's explanation for the blue color of the sea. So when he sailed back to India, when Raman sailed back to India after a few months, he just uh, did an experiment with a simple physics apparatus. That is, he has taken a prism, then a spectroscope and a diffraction grating. Then he used all these materials to study the sky, that is just to investigate why sky the color of sky is blue. Okay, and the sea. So he investigated using this instrument. He investigated or he used all those apparatus to study about sky and the sea, especially why both of them are blue in color. He found that scattering of light by water molecules is the reason for the color of the sea. So Raman has reported this, and his findings was published in a journal named Nature. Okay, this was the experimental setup that he has used to study about the color of sea and sky. Next one is about Raman effect. This Raman and most of his research student, both of them have done extensive research works in the topic regarding the scattering of light in their laboratory. They have studied this phenomena, that is scattering of light, in various mediums such as solid, liquid, and gas. Okay, now the violet color of the solar spectrum, they have isolated it with a violet filter and then they passed it through the liquid sample. What they observed was that most of the light emerging from the liquid sample is the same color as that of the incident violet beam. So the so-called Rayleigh scattered light, okay, that is called Rayleigh scattering and is named as Rayleigh scattered light. However, Raman and his students, they were able to show that some of the light scattered was of a different color. Okay, even though some of them was that same as that of the incident light, a few of them were different when compared with that of the incident light. And those different colors, uh, they have observed it using a green filter which is placed between the observer and the sample. So he has done these experiments in most of the substances and he noticed that nearly 60 different liquids have been studied and most of them showed the same result, that is some scattered light had a different color than the incident light. That was their observation. Okay, so he called it as Raman effect and he found that this effect is very weak, that is only 1 in a million of scattered light particles exhibits the change in wavelength. Okay, so he named it as a Raman effect. So Raman effect, the definition is as follows, that is when a beam of monochromatic light means light having single wavelength. Okay, so when such a monochromatic light is passed through an organic liquid such as benzene, toluene or carbon disulfide, what happens is that the scattered beam consists of other frequency in addition to the incident frequency. Okay, so the light will get scattered and and it will consist of frequencies in addition to the incident frequency. Now this scattering of light with such a change in frequency is called Raman scattering and this phenomenon is called Raman effect. So that is the exact definition for Raman effect. Okay, so study that very well. Now let us see how the Raman spectrum look like. See, this is a spectrum, that is a spectrum of scattered light will have a number of new lines are observed on either side of the parent line, that is Rayleigh line, that is one frequency will be same as that of the incident frequency, that will be the Rayleigh line, and some you can see some new lines or modified lines on either side of this Rayleigh line, they are called Raman lines. Okay, now lines having low frequency than the parent line are called Stokes line and those having higher frequency than parent line, that is Rayleigh line, are called anti-Stokes lines. So Stokes lines have more intensity when compared with anti-Stokes lines. So this is the definition for Raman spectrum and this is the definition for Raman effect. This is the explanation for Raman spectrum. That is, when you pass a monochromatic light through an organic liquid, definitely scattering takes place and the scattered light, when you observe the spectrum, you can notice that a particular line called Rayleigh line will have frequency same as that of the frequency of the incident light, whereas some new lines or modified lines, you can see it on either side of Rayleigh line, they are called Raman lines. One is Stokes line and the other is anti-Stokes line. Okay, so this scattering of light with such a change in frequency is called Raman scattering and this effect is Raman effect. Next is the explanation of this Raman effect based on quantum theory. A quantum of light, electromagnetic radiation, is called photon. Okay, so when a photon of frequency nu 0, suppose that it collide with a molecule of the scatter, that is imagine that there is a scattering object and a photon of a frequency nu 0 collide with the scatter, then three things may happen. The first thing is that sometimes the molecule of the scatter just deviates the photon without absorbing its energy, or sometimes it will give any additional energy to the photon. So the result of this process will lead to the appearance of Rayleigh line in the scattered spectrum. The second possibility is that the molecule may sometimes absorb a part of energy of the incident photon. If this occurs, then it will give rise to Stokes line with frequency less than that of the frequency of incident radiation. Now the third possibility is that the molecule, suppose that it is already in an excited state, then it will give some of its energy to the incident photon, and this process will give rise to anti-Stokes line with the frequency higher than the frequency of incident radiation. Okay, so these are the three possibilities. Sometimes the molecule will neither absorb energy nor it will give energy to the incident photon. That is, it will just deviate the incident photon. So if that occurs, then you will get Rayleigh line. Now, if the molecule absorbs energy from the incident radiation, you will get Stokes line. Now, if the molecule gives some of its energy to the incident photon, then you will get anti-Stokes line. Okay. Next is Raman Spectroscopy. Raman, he has developed a lot of method of non-destructive chemical analysis for both organic and inorganic compounds. Then this Raman spectroscopy can be applied not only to liquids but also to solid, liquid and aqueous solutions. Now let us see his contributions towards acoustics. Okay. Then he has studied most of the physics of musical sounds. That is, he has worked on the theory of transverse vibration of bowed string instruments. Then he even performed experiments with mechanically played violins. Then he also studied the uniqueness of Indian drums. Then he also analyzed the harmonic nature of sound of tabla and mridanga. And then he also brought about a correct theoretical explanation for the acousto-optic effect, and that was called the Raman theory. Then okay, so these are some of his contributions towards the field of acoustics. Then he also has carried out many experimental and theoretical studies on diffraction of light by acoustic waves of ultrasonic and hypersonic frequencies. Then he also studied about the effect of X-rays on infrared vibrations in crystals when exposed to ordinary light. Then he has studied about the spectroscopic behavior of crystals. Then he has studied about structure and properties of diamond. Then some other interest of C.V. Raman was the optics of colloids, electrical and magnetic anisotropy, then physiology of human vision, etc. Later, in 1924, he was elected as the Fellow of Royal Society, that is FRS, and then we have already said he has won Nobel Prize in Physics in 1930 for his discovery on scattering of light and Raman effect, and he was also awarded Bharat Ratna in 1954. Later, he became the director of Indian Institute of Science, and he founded out Indian Academy of Science, and he served as the president till 1970. Then he also founded the famous Raman Research Institute. Then he was its director. Then then in 1928, C.V. Raman and his research associate K.S. Krishnan discovered the inelastic scattering phenomena, that is Raman Effect, and that day is celebrated by Government of India's National Science Day every year in commemoration of the discovery. Okay, so about C.V. Raman, that is very important. So you have to brief his history, that is life history, as well as all his major discoveries. Okay, you have to explain each of his discoveries, especially Raman effect. Okay, this is a most probable essay question. Then Homi J. Baba. About Homi J. Baba, he is also an Indian-born nuclear physicist. His main topic of interest was nuclear physics. Okay, and he was also known as father of Indian nuclear program, and he was the first chairman of Atomic Energy Commission of India. He was from a wealthy family in Mumbai, and he was very influential in west of India. Okay, then he began his studies in mechanical engineering at Cambridge University. Then he was influenced by most of the theories of physics by Paul Dirac, and he has completed his mechanical engineering with first class. And then he remained in that university itself, that is Cambridge University, and continued his studies on theoretical physics. Later, he was received his doctorate degree, that is PhD degree, in nuclear physics from Cambridge University in 1934. Now, let us see about some of his contributions. One is Baba scattering. That is, in 1935, he published a paper in the Proceedings of Royal Society, and he performed the first calculation to determine cross section of electron positron scattering. Okay, that was his first contribution. He studied about the cross section of electron positron scattering. Then he conducted a lot of investigations on that topic, uh, and that study was later named as Baba scattering. Okay. Next is his contribution towards the discovery of cosmic rays. He has conducted a lot of research with Walter Hitler, and in 1936 they both of them have made a breakthrough in the cosmic radiation understanding by working on cascade theory of electron showers. Cosmic rays means it's actually a radiation that is coming from outer space. Okay. Uh, their theory described how primary cosmic rays from outer space interact with upper atmosphere, thereby producing particles at ground level, and they have estimated the number of electrons in cascade process at different heights for different electron initiation energies. That is, cosmic rays is a sort of radiation coming from outer space. So what Baba and his co-worker studied was that they actually determined how these cosmic rays coming from outer space interact with the particles in the upper atmosphere. Okay, then they also estimated the number of electrons that are produced during the cascade process of cosmic rays produced at different height for different electron initiations energies. Okay, or for different electron energies. Now, cosmic rays, the definition is that they are extremely penetrating radiations coming from outer space. The nuclei of hydrogen, we know they make up nearly 90% of cosmic rays. The remaining 10% are made up of nuclei of heavier elements such as helium. So unlike most particles, cosmic rays have extremely very high energy, and they travel at very high speed through space, nearly with the speed of light. Okay, so cosmic rays do not get far into atmosphere before they collide with the nitrogen or oxygen molecules in the air. Now, cosmic rays from space are termed primary, and the particles created in the atmosphere from collisions are termed secondary. Now, these secondary cosmic rays spread out and they continue to hit other particles and air molecules, thereby creating a cascade. Cascade means shower of particles called cosmic ray showers. Okay, so primary cosmic ray, they will create secondary particles. They will again continue to hit with the other particles in the atmosphere, and this will produce cosmic ray showers. Okay, uh, although their exact source is mysterious, it is assumed that they actually originate from sun, that is from outside of the solar system, and from distant galaxies or from supernova explosions, that is the origin of cosmic ray showers. Okay, then, so this cosmic radiation's understanding by working on cascade theory of electron showers was one of the breakthrough discovery of Baba and his co-worker Hitler. Okay, so their theory described how primary cosmic rays from outer space interact with upper atmosphere, producing observed particles at ground level, and they just estimated the number of electrons in cascade process at different altitudes for different electron initiation energies, which is the same sentence we have already said. So that was their aim of study, and later they understood that it was about cosmic ray showers, and the exact source of cosmic ray showers is not known. They just assume that they may originate from sun or from anything outside solar system, maybe from distant galaxies or supernova explosions. Okay, so the main contribution of Baba is on cosmic ray showers, and Baba scattering. Then He established Cosmic Ray Research Institute at Indian Institute of Science in Bangalore, and he was also selected as Fellow of Royal Society FRS, and he was the director of Tata Institute of Fundamental Research TIFR in 1945 and Trombay Atomic Energy Establishment. Then he became the first chairman of Atomic Energy Commission of India in 1948, and he realized the potential of India regarding the thorium deposit, that is a radioactive deposit thorium, and also about another radioactive deposit like uranium. And under his guidance, Indian scientists worked on the development of atomic energy, and the first atomic reactor in Asia went into the operation at Trombay, that is in Mumbai, 1956. And then he was also the chairman of the first United Nations conference on peaceful uses of atomic energy, which was held in Geneva in 1955. And these are some of his professional um, positions that he have acquired in the field of nuclear energy. Then he also was conferred with the Padma Bhushan award for his outstanding contributions to nuclear science. Okay, so these are some of his awards and the positions that he has engaged. Okay, so that's all for today. Please read through it. Thank you.